Hello, welcome to Regular Shivers Educational Limited. Today, we are going to continue from where we stopped the last time by reviewing the AQA GCSE Physics Paper 2. For today, we'll be looking at waves. In our last class, we were able to review the topic on forces. Waves. In this topic, we will explore what waves are, how they transfer energy, their properties, and their behavior when they meet different materials. We'll also study sound, electromagnetic waves, lenses, and visible light. More so, at the end of this material, we'll also take time to take a look at a typical sample on the GCSE past question that aligns with the topic waves. There are some key terms and basics you need to know when it has to do with this topic. Wavelength is the distance between two identical points on consecutive waves, while amplitude is the maximum displacement from the rest position. The frequency is the number of waves passing a point per second. Period is the time for one full wave to pass a point. Then the wave speed equation is the V equals to the frequency multiplied by the wavelength. The period and frequency relation is such that T equals to 1 divided by frequency, or F equals to 1 divided by time. Types of waves. Typically, we have two types of waves. One is called the transverse waves. In transverse waves, vibrations are at right angles to the direction of travel. We can see that in the likes of the light waves, electromagnetic waves, and water waves. In longitudinal waves, vibrations are in the same direction as travel. We can see that one in sound waves. The wave travels through the medium, but the particles only vibrate. They do not move with the wave. Measuring wave speed. Sound in here, we can use echoes. It measures the time for sound to reflect from a wall and return. Or we can use two microphones and a data logger to measure the time difference between detections. Ripples on water is another typical sample when we want to measure wave speed. You can use a stroboscope to measure wavelength or time the motion of wave front. Then you can apply the formula V equals to the frequency multiplied by wavelength, or speed equals to distance over time to determine the speed. Wave interaction. When wave meets a boundary between two materials, they can be 1, reflected. That means they can bounce off the surface. 2, they can be transmitted. That means they can pass through the material. 3, they can be absorbed. That means the energy taken in by the material often as heat. Reflection. Smooth surfaces reflect light evenly, like a clear reflection, but rough surfaces scatter the light, like dull or matte appearance. And the law of reflection states that the angle of incidence is equal to the angle of reflection. And opaque materials reflect light if not absorbed by electrons. Transmission and absorption. In transmission, transparent materials allow light to pass through. But in absorption, specific frequencies are absorbed by electrons and later released as heat. Example, a green object reflects green light but absorbs other colors. Sound waves. Sound is a longitudinal wave that travels through solids, liquids, and gases. It causes vibration in solids such as the eardrum. Vibration passes through small bones to the cochlea, where ears dictate different frequencies and send signals to the brain. Human hearing and limitation. Human ear between 20 Hz and 20,000 Hz. Okay, that is the range in which we can hear a sound. The high frequency hearing decreases with age or loud noise damage. That means it's not going to be at that frequency forever. As you are growing old, it's going to keep reducing. Animals that use sonar, like bats, can detect ultrasound, unlike humans. Ultrasound. Ultrasound, their sound above 20,000 Hz. When ultrasound hits boundaries, some waves reflect back. The reflection time shows distance or depth and is often used for the medical scanning, industrial testing for cracks in materials, sonar to detect fish or seabed depth. Infrasound helps study earthquake and Earth's structure using the P and S waves. electromagnetic waves. All electromagnetic waves, they are transverse and they travel at the speed of light, which is 3 times 10 raised power of 8 meter per second in a vacuum. They transfer energy from one place to another without needing particles. Examples: we have microwaves that eat your food. We have the sunlight that warms the heart. As wavelength decreases, the frequency and the energy increase. The electromagnetic spectrum. There is an order of increasing frequency and decreasing wavelength in EM spectrum. So it ranges from the radio waves to the microwave to the infrared rays to the visible light, the ultraviolet, the X-rays, and the gamma rays. And all share the same speed in space, but they have different uses and effects. Refraction and dispersion. When light enters a denser medium, it slows down and it bends towards the normal. Entering a less dense medium, it bends away from the normal. But in dispersion, when light splits in a prism, when you see the light is going to split in a prism, and that is because each color will refract differently, like blue blends more than red. Radio waves and EM emission. The radio waves are made by oscillations in electrical cycles. When they are absorbed, they produce alternating current of the same frequency. EM radiation can also be emitted when electrons change energy levels within atoms. Hazards and uses of EM. Some of the hazards of EM has to do with the ultraviolet. It can cause skin aging or skin cancer. The likes of X-rays and gamma, it can cause ionization radiation that can damage the cells and cause mutation. And some of the uses ranges from the use of like the radio wave in broadcasting and communication, the microwave often used in cooking and satellite links, the infrared rays often used in heating and night vision cameras, and the visible light is often used in the fiber optics. Lenses. We have convex lens and concave lens. In convex lens, the light converge, The converged light rays is often used, in convex lens. And this converged light rays is used as magnifier, is used in the camera, is used in the long-sightedness correction, But in the concave lenses, we use the diverged light rays and it's often used to correct, the short-sightedness. The rays passing through the lens center travel straight, while others bend through the focal point. Visible light and color. Each color has its own wavelength and frequency. For example, the blue has the shorter wavelength but it has the highest frequency. The red, it has a longer wavelength but it has a lower frequency. While the white light, it is a mix of all color, and black absorbs all wavelengths. Color filters transmit only selected wavelength only. Black body, radiation, and space. All objects emit and absorb infrared radiation. Other objects, they emit more radiation and shorter wavelengths. A black body, they absorbs all radiation and emits it efficiently. Earth's temperature depends on how much radiation it absorbs, and it re-emits through the atmosphere, and that is what we often refer to as the greenhouse effect. In conclusion, wave transfers energy without transferring matter. They can reflect, refract, and be absorbed depending on the material they meet. From sound and ultrasound to the full electromagnetic spectrum, waves helps us communicate, observe, and explore the world around us. So we'll move forward now by reviewing some questions in line with waves. The first question says that there are different groups of waves in the electromagnetic spectrum. Figure 1 shows the position of 3 groups of the waves. Which letter shows the position of infrared? If you take a look at the material we just reviewed before now, I was able to show you the pattern that it follows. So basically in line with that, so the position that shows that of infrared is going to be B, because after the microwaves, you have your infrared rays, then after that, you have your visible light. All right, so the second question that says, a student investigated how the color of a surface affects the amount of infrared the surface absorbs. Figure 2 shows the equipment being used. You can see the equipment right there and the setup. Then I say choose the answer from the box. If you look at the box, we have the control, the dependent, the independent. In this investigation, the distance between each flask and the infrared heater is dash variable. Is it dependent or independent, or is it a control? So basically, the distance between each flask, okay, and the infrared heater, this is what we're talking about. Look at it. Let me go back a bit. You can see we have silver color flask, we have black colored flask. Okay, if you take a look at them, you realize that they are all connected with the thermometers where to regulate the temperature. So basically, those two flasks, okay, the distance between the two flasks and the infrared heater is referred to as a control variable. The next one says the student wrote the hypothesis. Surface color of the flask affects the amount of infrared absorbed when the heater is switched on for 5 minutes. Describe how the equipment in figure 2 could be used to test this hypothesis. This is the 4 marker, so it's important for you to be well detailed while you are doing the description. Very, very important. So the very first thing you need to do is to record the initial temperature. You need to first record the initial temperature of the two thermometers in the flask. You record the initial temperature. Okay, of the two thermometers in each flask. Then after that, the next thing you want to do is to switch the infrared heater on and start the stop clock. You need to switch the infrared heater off, then you start the stop clock. Then after 5 minutes, you record the final temperature from both flasks. And the last thing you want to do is to check if the temperature inside the flask had increased by different amounts within that 5 minutes. That is a brief, what's it called, investigation that can be done in that regards. The table below shows the results. You can see the color of flask, black and silver. They say which one of the results for the black flask is anomalous. Which one is anomalous? It's surely going to be during the test 3 of the black one. You can see the difference between 19, 17 for test 1 and test 2 is far much to that of test 3. Then the next one says the anomalous result was caused by reading the thermometer incorrectly. What should the students do with the anomalous result? What they just need to do is to ignore it. They can make do with the test 1 and test 2 only. Then the next one says calculate the mean temperature increase for the silver flask. The mean temperature increase for the silver flask. We go to the silver flask. Okay, so what do? You add it all together. 10 plus 12 plus 11. That will give you 33. Since it's 3 test results we are comparing, that will be 33 divided by 3, and that will give you 11. Okay, so the next one says, what conclusion can be made from the table above? One key conclusion that can be made is that the black flask absorbed the most infrared during the 5 minutes. The black flask absorbed the most infrared during the 5 minutes. Let's go up. Look at it. You can see for test 1 and test 2, you can see the way the temperature increases. So that shows the black flask that, that absorb the most infrared during that 5 minutes. Then the next one says, the data given in the table below was obtained from an investigation into the refraction of light. Okay, we can see the angle of incidence and we can see the angle of refraction. And so we should describe an investigation a student could complete in order to obtain similar data to that given in the table above. Your answer should be considered any cause of inaccuracy in the data, and a label diagram may be drawn as part of your answer. Let's first take a look at the marker. Okay, basically this is a 6 marker, so you need to be quite very, very detailed so I can get the 6 marker completely. And funny enough, if you give the wrong answer, you just get a 0 marker while you think you're providing full information. So they also describe an investigation a student could complete in order to obtain similar data to that given in the table above. Okay, so one of the things is that the student can place a glass block on a piece of paper, and thereafter can draw around the glass block and then remove from the paper. Then you now draw a line at 90 degrees to one side of the block. Then use a protractor to measure and then draw a line at an angle of 20 degrees to the normal. Then now replace the glass block. Then thereafter, you use a ray box and slit point the ray of light down the drawn line. Then next, you mark the ray of light emerging from the block, remove the block and draw in the refracted ray. Then you measure the angle of refraction with a protractor. Okay, then you repeat the procedure for a range of values of the angle of incidence so that you'll be able to have your different value, and it's just going to be similar like what we have right here. Okay, so the next question says that a student investigated how the magnification produced by convex lens varies with the distance between the objects. The students used the apparatus shown in figure 1. They said the student measured the magnification produced by the lens by measuring the image height in centimeter. Explain why the image height in centimeter was the same as the magnification. Okay, because we know that magnification originally is what? Is your image height over the object height. Magnification is the image height over the object height. So dividing by any object height of 1 centimeter will give you the same value. So that is the reason. The next one says the data recorded by the student given in table 1. You can see the table 1, the distance between the object and the lens in centimeter. And at the same time, we have the magnification. So let's move on. Then I say it will be difficult to obtain accurate magnification values for distance greater than 60 centimeters. So just one change that could be made so that accurate magnification values could be obtained for distance greater than 60 centimeters. Okay, one of the things they can do is that we can use a taller object. Or you can use a microscope as well. Either of the two can actually help out. Then the graph in figure 2 is incomplete. The graph in figure 2 is incomplete. Then I say complete the graph 2 by plotting the missing data and then drawing the line best fit. Okay, if you look at the line we have here already, we have 1, we have 2, we have 3. So basically, we just need to complete the graph by plotting the missing data. So if you look at this, on magnification is 2.0 and the distance of the object is 30. So we'll go back to that table. Okay, so you can see right there so that you can get those values. When it is 1.0, it is 40. Okay, when it is 1.0, it is 40. Okay, when it is 60, it is 0.5. Okay, when it is 50, it is 0.7. This is 50 here. So 0.7 will likely be around anywhere here. 50 is 0.7 is going to be somewhere around there. Okay. 1, 2, 3, 4. How many remain? But when it's 25, it is 4, and when it's 30, it is 2. When it's 30, it is 2. When it's 25, it is 4. It's 25. 25 is in the middle, and that is going to be 4. Okay, so basically 1, 2, 3, 4, 5. How many do we have? 1, 2, 3, 4, 5. Good, is complete. So at this point now, you can now plot the graph, and it's going to be a curved one. Don't mind my hand, not that straight. So it's going to be a curved one. So this is how the graph is going to look like. And then you have the 2 marker. So how many times bigger is the image when the object? How many times bigger is the image when the object is 35 centimeters from the lens compared to when the object is 55 centimeters from the lens? So all you need to look at is to compare the difference. When it is 35 centimeters, you trace it. Okay, you trace it to the
y-axis, that will be around 1.4. And when it is 55 centimeter, you trace it to the y-axis, and that will be around 0, somewhere like this. That's going to be around 0.6. Okay, so what do you need to do? You now find the difference. You now find the difference so that you know how bigger is going to be, because it's how many times bigger is the image when the object is 35 centimeter, okay, from the lens, compared to when the object is 55 centimeter from the lens. So just find the difference. Then when you find the difference, then you'll be able to determine how big is going to be. Now determine how big is going to be, because basically you're already giving, what is it called, the magnification for the two of them. They've given you the magnification, okay? So you just determine how big is going to be in that regard. So basically I can do for 35 centimeter, we know that the 35 centimeter is 1.5, 1.4 rather. And we know that for the other one, 55 centimeter is 0.6 already. Okay. So basically, we can see that the difference between the two of them is just 0.8. That is the much difference in their magnification. Okay, they say this during the investigation, the student also measured the distance between the lens and the image until the two gives both of the distance measured in the magnification. They say give a second way that the student could have determined the magnification of the object. And that is by dividing the distance between the lens and the image by the distance between the lens and the object. That is another way to have actually gone through that method. Okay. Then the next question says, what name is given to the group of waves at the position labeled A in the figure above? I think the figure will probably be below. I'm not sure whether it's been given. Okay, so we'll stop here. We'll stop here for now. 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 Hopefully, in our next class, we'll move on to the next topic under paper 2 of AQA GCSE Physics Review. I do hope you've learned something today. Do well to subscribe and follow for more. Thank you so much for following Regular Shivas Educational Limited today. See you some other time. Bye-bye.